Hello, dear students. I am Samir Velankar. I welcome all of you to this next video on structures in C. We are looking at a topic called self-referential structure in C. Actually, I should say that this is just the beginning of data structures in C. Basically, I am going to teach the topic or the subject programming and data structures, and we were learning programming all this time in C. And it's time actually now to go ahead with our next subject called data structures in C. But I have not yet officially started data structures in this video. But then we are getting prepared. You will see the first video on data structures in the other section. So what is this self-referential structure? Check the definition. Structure having pointer. So inside a structure, structure has many members. It can have one or more members. Structure having pointer of the same type as that of structure is called self-referential structure. An example will tell you. Suppose we are declaring a structure called node. So I have given this name as node because mostly, in data structures like linked list, binary tree, it is often a practice to name the structure as node. Okay, so this structure is named as node, and node contains an integer data, int member we say, int data. And look at this declaration. Here, next is a pointer. Definitely next is a pointer. But pointer of what type? What can next point to? Next can point to a node. Next can store address of a node, which is a struct type. So if you imagine a node structure in the memory, the node structure can contain integer data, something like 10, and it will have a pointer named as next. And this next pointer, as it is a pointer, can store address. But whose address? Check the definition again. Next is a pointer which can store address of a node, which is of struct type. So you all know that this itself is a node. This is a node structure. And this node structure contains a pointer which can store address of another structure of node type. So in the memory, suppose we have one more node structure. See, the type of this structure is node structure, and type of this structure is also node. So this can also store some integer data and will have a pointer called next, another member. Now what we can do is, whatever is the address of the second node, which is storing 20, maybe the address of this second node is 200. I'm saying base address of this structure is 200. Then this next pointer can literally store 200. That means this next pointer will point to this second structure. Of course, the first structure will also have some address, let's say 100. And what if we have one more structure like this? This is also node structure. Suppose it is storing 30 and it has a pointer called next. Of course, every node structure will have data and pointer because that's what we have declared in the node structure. If the address of this structure is 300 in the memory, then this next has ability to store 300 and it can point to this node structure. Note, the next can point to this structure only because the structure which I am encircling now is a node structure. It's a node structure. So next can point to any node structure, and all these are node structures. This gives us an idea about the concept of linked list. I said in early in the video that we are actually, we are setting up the stage as we are learning C programming. I thought before we leave C programming and enter data structures, why don't we get used to some conventions? So you see this type of diagram is called linked list, because what we are having is we are having node, again a node, again a node, and all these nodes are connected to each other using a link. You can just check this arrow is as good as a link. So it is a list of linked list is basically a list of nodes connected by pointers. That's the simple definition of linked list. Although we are not looking technically at linked list, that was not the topic of this video at all. But self-referential structures have their place, have their application in creating data structures like linked list, stack, binary tree, graphs, many, many more applications. Because what you want to do, you have some data to store. If you have some data to store, you would not have always data like integer like 10. Say you have a data of a student. So you will create a structure, store roll number of the student, store name of the student, and then store marks. But you have another student in the same memory which has roll number, which has name, let's say some name ABC, ABC is the name, and some marks. But then what you want is that you should be able to go to every student or traverse to every student and process this list of students, process them. So what you will do is you will use some kind of pointer called next. Now this next pointer is a member of the structure itself, and this next pointer has ability to store address of any structure of the same type. So here also we will have next in the second node, which can store address of the next structure, which again can store the same type of data, roll number, name, and marks, and this may go on. Well, if this is the last student in the list, suppose, then this next, which is a pointer to the next node actually, cannot store anybody's address. In such case, we make this next equal to null. From the earlier videos, we know null means empty as far as pointers are concerned. If you make a pointer empty, then it means that the pointer doesn't point anywhere. Well, I show these null pointers by a ground symbol. Many other authors have many other conventions. But if you see in the diagram that some pointer like next has been grounded, it means that that pointer is storing a null value. And we say that the list starts here. This next will take us, the arrow pointing to the second node. The second node has next, which will take us to the third node, and third node has next, which is grounded. So it will take us nowhere. And on seeing this null, we can know that the list ends here. So what is self-referential structure? Let's go through the definition again. A structure having pointer of the same type as that of structure is called self-referential structure. And the example shows that a node structure has a pointer called next of node type. So that's what has been written here. Now I will go to a bigger code now. Now let's see what this code is doing. Let's execute it line by line and see. You can just take this as fun and you can say that, okay, I'm getting acquainted, I'm getting prepared for advanced topics like linked list. Now in this code, I have again declared a node structure, okay, which contains data in data and a pointer called next, which can point to any node of struct type. But you know, declaring this node is not enough because this is just the data type. You should create variables of this type so that you can store values. Let's see what we are doing in main. In main, we have declared pointers. Observe carefully, first and temp are pointers of node type. So actually there is big difference in writing this line, node struct node, I'm so sorry for this, struct node n1, n2, n3 or something like this. Now what are n1, n2, n3? They are variables of exactly node type. So in the memory, n1 will be a block which is of node type, which is of node type. So it can store data and it will have pointer. So what is n2? N2 is also a variable. It can store data and it will have pointer. Same goes with n3. But first and temp, observe the cursor place. First and temp are not structures. They are pointer to structures. So first is not going to store any integer data and next pointer. First will store only address. Similarly, temp will store address. So in the beginning of the code here in main, we are having a pointer called first and we are having a pointer called temp. And first has ability to point to a node structure and temp has ability to point to a node structure because both are node pointers. But the problem is we are not having any node yet. So how do you get a node? We will use malloc. Just 2 videos back, we saw how to create a structure dynamically using malloc. So how do you read this line? First, which is a pointer of node type. First, which is a pointer of node type, should point to newly allocated memory. Malloc will allocate the memory and memory allocated will be exactly equal to memory required for one node. So memory required for one node will be allocated. By the way, if we assume that int data consumes 2 bytes and pointer next consumes 2 bytes, then exactly 4 bytes will be allocated by malloc because size of node will be 4. But let's not go into that details. Definitely data will be there and next will be there. And whatever is the base address of this, maybe 100, at which the new node was allocated, will be stored by first. As you see, as you see at this line, first stores the address of newly allocated node. So first will point to this node. And you also again see there is no name to this node. If there was a name like n1, we would have written n1 dot data or n1 dot next, but there isn't any name to this node. But then we can reach this data or reach the next by writing first arrow data or first arrow next. So that's what we have done in the next line. First arrow data is 10. So here we go. First arrow, this node's data is 10. So we have successfully stored an integer value in this data. Next line says first arrow next should be null. So here we go. First arrow next, this node's next should be null. Null means empty and I have a habit of showing null pointer as a ground symbol. So this next pointer is not pointing to any node or any place or any location in the memory. This next pointer is empty. Next line you observe, temp is another pointer, isn't it? And it also points to a new node because we are using malloc and allocating memory for new node. So absolutely a new node gets created or allocated, which again has data and pointer called next. But the allocation will be done at some address. Let's say address is 200. Then temp is going to store 200 and temp points to this node. Again observe there is no name to this node. But then we can access data or next by using temp arrow data, temp arrow next. That's what we have done in the next line. Temp arrow data is 20 we have said. So this data will become 20 and the next line is, as you are reading, temp arrow next is null. So this next, temp arrow next is null, it doesn't store anybody's address. Now comes the fun part. This next line, which I am encircling here, check, is the core crux of how you use that next pointer. We are saying first arrow next equal to temp. So first of all, you search in the diagram, where is first arrow next? Trace the cursor place. First, this is first, arrow, next. We are talking about this next should become equal to temp. Now this is exactly pointer equal to pointer. We read this line as first arrow next should point to the same location where temp points. And observe that temp is pointing to 200. So first arrow next will literally become equal to temp. So this next will become 200. What that means is this next will no more be null. It will no more be null, but it will point to 200 because we have made first arrow next, this pointer next, equal to temp, isn't it? Here is temp, and temp is 200. So 200 has got literally copied in first arrow next. So next points this node. You're watching now, we have created a node and that node is connected to other node. We can say this first node has address of second node. We could have continued. We could have created third node, but I just don't want to go into intricacies of creating a linked list. But I am sure whatever we have done till now was really satisfactory, and we have got, we can say, miniature linked list of two nodes. So I'll just clean the slate what we have got till now. Let's see very quickly. We have got a node storing data as 10 and a pointer called next. This next is storing 200 because this next is pointing to a node at 200 which has data equal to 20, and the next pointer over here has been purposely made null because there is nothing to follow this. There is a temp pointer which is storing 200 and it is pointing to the node at 200. There is a pointer called first which is storing 100, the address of the very first node, and it is pointing to the first node. Now let's print some outputs. The printf to which I am pointing here will print value stored in the first node in %d format. Check that it is printing first arrow data. So if you follow the mouse cursor, first arrow data is going to be 10. So first output will be 10. The second output is the value of the second node we are printing, which is temp arrow data. So temp arrow data, you observe this temp arrow data is 20. So the second output will be 20. But the last thing is very fun, a lot of fun here. We are printing value stored in the second node again. Have you printed it? First arrow next, arrow data. Just follow the mouse. First arrow next, this next, again arrow data. That means we have reached the second node. By using this convention here, we have reached the second node. So the output of this node will be 20. All right then. So this is how we are using self-referential structure. I hope you have understood the definition. Lots and lots of applications of self-referential structures in data structures. Thank you very much.